Hello, I'm Mr. Clark, and we're going to have a look in this video at how to do Hess's law cycles using combustion data. So I'm going to have a look at one of the questions from your worksheet. It's from the Hess calculations worksheet, number 9. It says calculate the enthalpy change for the hydrogenation of benzene to cyclohexane. So we've got benzene C6H6 plus hydrogen goes to cyclohexane C6H12. What we're going to do is write the combustion products of this reaction. So the combustion products are carbon dioxide and water, and we are going to just balance that, so 6 carbons there and 6 waters. Now, to complete the Hess's law cycle, we are going to add in arrows, and for combustion data the arrows go downwards because we're going from here and these are the products. So this is the reaction that we've got there. An easy way to remember it is that in a house you build the house up, so when you use formation arrows you put the arrows up and you burn the house down. So when you use combustion data, enthalpies of combustion data, the arrows go downwards. The next thing I'm going to do is just arbitrarily assign some algebra to it. So let's just do this as delta H1, delta H2 and delta H3. So let's plug in some of the numbers. We're given some combustion data over here, so if we just plug in some of the numbers for that, we can put minus 3267 for benzene. We've got 3 lots of hydrogen being burned, so it would be 3 times minus 286. And over on this side, the enthalpy of combustion of cyclohexane is minus 3920. So Hess's law states that the total enthalpy change of reaction is the same regardless of the route taken. So what we're going to do is just track the arrows. So this arrow goes the same way. So that plus that equals the other way round. So whichever way the arrows point, so that arrow plus that arrow equals that arrow. So let's take our algebra and just write a simple equation. So delta H1 plus delta H2 equals delta H3. Let's now just plug in some numbers to that. So we've got delta H1 plus minus 3920. My advice to you is you're going to look at that and go, well, that's minus 3920. Just keep things in brackets for a little while. Don't do too many manipulations of signs in your head. So let's just track it through properly. And that would equal minus 3267 plus 3 times minus 286. So let's just, in the next line, just crunch through some of those calculations. So let's rewrite it. We've got delta H1 is now minus 3920, and the total for that side is minus 4125. So hopefully now you can see, if we add on 3920 to both sides, we'll get delta H1 on its own. So we should end up with that equaling minus 205. So delta H1 is minus 205, so your final answer is minus 205 kilojoules per mole. Thanks for watching, hope that was helpful to you. Bye now.